All right, I get a thumbs up down there. So thank you so much, guys. Well done. Hello everybody. My name is Bjorn Mo. I'm a platform architect at Pivotal. What on earth does that mean? It really means I'm a techie guy. I've been writing code back in the days for I don't know how many years. And these days, I spend a lot of time with customers and clients, really talking to them about how they build software, how they're doing it right now, how to kind of bring that to the next level, modernize the way they do it. It's not a secret, given the kind of conference we're at here, of course, I spend a lot of time talking about Cloud Foundry, how do you write software to properly take advantage of that type of cloud-based platform. So I'm going to go beyond a little bit just getting started on technology and really talk about kind of what happens. I call it like day 2 development. You got to start on a project, things are going great, we're doing microservices, everything is fantastic. And you realize that there are new challenges coming into play that you may not necessarily have dealt with before. And there are things that you need to think about that may be a little different compared to how you've been approaching certain types of problems in the past. So just as a quick hands up, who here is building microservices today? Quite a lot of people. That's awesome. How many are using Spring? Of course, that was a given. Thank you. And finally, how many are using the Spring Cloud frameworks? That's great. Quite a few people. That's awesome. So that means, for you guys who are doing that, it's not just that you're doing kind of microservices by accident. I see that quite a bit around where they happen to be building RESTful services. They kind of make it work, kind of scared of calling it microservices, but that's really what they're doing, kind of by accident, and they kind of make it work. Now, in this case here, it's really about the story about a team who has this monolithic application, it's been around for a long time, and it's kind of been growing over time to become this big beast. And they realize, hey, it's hard to maintain this thing, it's hard to add more features to it. We're not really confident in ourselves when we're trying to do anything to it either, whether it's going to work afterwards, fixing bugs and releasing those bug fixes is always being really nervous doing it at 3 o'clock in the morning, all that good fun stuff that comes along with that kind of applications over time. And of course, nobody wanted to end up there, but that's kind of where you end up over time. So it was a good story about how on earth that happened. But anyway, they suddenly realized that, hey, we need to do something about this. We're following all the best practice, everything that people are preaching in terms of splitting up into 2 pizza teams, because that's what we're supposed to be doing. We're going to do microservices, and everything is going to be great, right? Sounds fantastic. And of course, if you're going to do microservices, yeah, you better be doing it on Cloud Foundry, of course. That's a given. So far, so good. Well, there are some questions coming up as well when you start going down this path. And one is a very basic question, which is a matter of communication. How do these teams work together to start building something that becomes a solution as a whole? And because you're going to find that some teams are more concerned about building services that others are supposed to be consuming. And you would then think like, well, the answer to that question is very straightforward. You do RESTful services, you use some JSON, and you're good to go. It's not that complicated, right? And technically speaking, it's not. The bigger question is, how do you make sure that the services are built are actually the right services that are to be consumed by whoever is going to build more of the front end? And what you tend to do then is, okay, maybe you'll do some actual teamwork. You'll sit down, you look at the requirements, see what the business wants, and you come up with an agreement, a specification in terms of, in order to deliver this functionality, these are the APIs that I need. So you get to the point where you get to an agreement on that. You write it down, put it into a nice, shiny Word document everybody agrees upon. You save it somewhere, and then you kind of forget about it. And that sounds like a good strategy, right? And ideally speaking, when you do that, you set it up in a way so that the team who's building the services, they get started, they get start building all those great APIs that you're looking for. When that team is done building those APIs, then the front-end guys and gals can get started and build their front end. They can consume those APIs, and we're all happy. Everything is fantastic. Well, reality is that it doesn't always work this way. Really what tends to happen is that API that you're relying on, that is under construction. It's going to remain under construction for quite some time. You realize suddenly that you're on different teams with different priorities, where you as a front-end team, you realize that you cannot afford to wait for the other team to actually finish their work before you can get started. Because if you do that, you're going to miss your deadline and you're going to look bad. And that other team, they say, well, we're busy with something else at the moment, but we promise we are going to deliver at some point, and it's going to be just in time for when you need to deliver your stuff. So if you're in that kind of situation, you have no way of influencing that. What on earth are you supposed to do? Well, what tends to happen, or a very common strategy to kind of address that, is to start mocking up those APIs that you need. So in that way, you as a consumer, you don't have to wait for the producer to build those APIs that you rely on. You take a look at that Word document that was created, you look at the APIs there, and you say, okay, this is the stuff I need. I'll just mock that up myself, not a problem. And in that way, I can keep on going at the pace that I want. I'm not being held back by anybody else. And I'll be good. I'll get to the point where I need, and all my unit tests in my CS system, they're running green, and everything is good, and everybody's happy, right? And that's not a bad idea. I mean, if you think about it, with the Spring Framework, we've been preaching mocking as a part of a unit testing strategy for 10 plus years now. It was one of the big things that the Spring guys started preaching back in the days. And it really has some real benefits, especially when it comes to doing proper unit testing and doing focused unit testing. It also helps because we're not relying on the real implementation to even exist yet, which means that, once again, the consumer gets implemented faster, consumer build runs green, we're happy, we're not really held back by everybody else. And the only caveat to what we're doing here is that we can't really do proper end-to-end integration testing, because in order to do that kind of integration testing, what you're going to be integrating with actually has to exist. So we'll have to wait with that, and one day when the other team is done with the service that we depend on, then we'll flip some switches, we'll turn our integration tests, and hopefully this will work, because this is the last thing we need to do before we actually go into production. Of course, it doesn't go that well. And these are like the fantastic kind of bugs and errors to deal with, because they always happen late in the development cycle. When you're the most stressed out, you're almost done, just make this thing work together, everybody. We already lined it all up, and we just can't get it working. And it's a pain to fix, it's expensive, and not at least, it's extremely stressful to deal with this stuff. So what went wrong? Well, you got really two different worlds you're dealing with here that are going against each other. You got that unicorn world on the one side, where you as a client-side developer, you're looking at the world through your view, the way you think it should be working, and you mock it up and you make it work. And it turns out that that world does not match the real world and the real API that gets built. And there are, of course, a lot of good stories around why that happened. I mean, there's always a good reason for it. Sometimes things get lost in translation. Sometimes you realize that we had to make a few changes here and there, either in order to implement the client or the server in the right way, and try to put it back into that Word document that nobody reads anyway, and it just gets lost on the way. There are also some more fundamental problems here that just adds on to the damage and kind of sets you up not for success but failure. Some of it boils down to who's actually managing those stubs in the first place. Yes, it's the clients that needs them, but if they're holding on to them, if they're building them, that represents their view of the world and their interpretation of what needs to be delivered the best they can, which may not necessarily be the same as what's actually going to be delivered by the server team. It also means that those stubs are not being used to validate that their server team actually builds the same thing. So in that way, you have two different implementations, essentially, that may or may not match. So the question is then, how do you even guarantee that those steps are valid? You built them, you hope they work, but you have no way of guaranteeing that they work. And you may actually make them work at day one, when you do your version 1.0 release of your software. But as time progresses, as you keep on changing the system, do maintenance on it, it becomes harder and harder to actually maintain these things. And to make matters even more interesting, if you're running an even larger project where you have multiple consumers relying on the same service that is not there yet, you are going to end up in a situation where you have multiple teams building multiple stubs, multiple mocks of the same service, and not even them may actually look the same way. So in that way, you have duplication of effort. And if you're unlucky, you have not only a duplication of effort, but you may have multiple views on how the same service should work, and they may all actually be wrong, which just makes matters even worse for you. So what are you supposed to do? I mean, does this mean that this was a really bad idea? Not necessarily. I mean, mocking itself is not bad, and especially, I mean, if the producer doesn't even exist, what on earth are you supposed to do? There are, however, some philosophical things in terms of how we approach this problem that is worth emphasizing and rethinking compared to the way we're usually used to thinking about service providers and the APIs they provide. First of all, if you think about where your requirements usually tend to come from, they come from a business user somewhere, and they view the world very often is more in terms of from an end user point of view. This user needs to be able to do these and these things. So it means already there, the requirements and who's actually driving the APIs itself is actually coming from the consumer, not from the server side. It's not, so that's one aspect of it. And that also means that not only should the consumers take part in defining the APIs, but it also means that they actually should be the ones driving the design of the API and really telling these are the things we actually need. And this is really what is a concept called consumer-driven contracts. That is a concept that really reinforces that in terms of who is actually supposed to be defining these contracts and defining the APIs. It's not necessarily the server-side people who are building them. It really is more a matter of that letting the consumer, the customer in many ways, define what they actually need. And I think for us as people, that's a very different way of thinking compared to the way we're used to dealing with things like that. I mean, if you think about it, us as techie people, we're used to seeing EULAs all over the place and user license agreements, right? A lot of text, and you have two buttons underneath it, accept or decline, and you have no choice. There's no way for you to negotiate this thing. Same thing, you're going by a new cell phone, and you get this enormous contract by whatever cell phone provider you're dealing with. And once again, the only option you have if you want that service is to sign the dotted line. And it's really the provider of the service you're buying that holds all the power in terms of what you actually get to do. This is a different way of thinking. We're turning the tables completely on this. We're saying it's really the consumer who knows best what they need, and they are the ones who really should be driving what actually gets delivered. In addition to that, that API specification that ended up very beautifully in the Word document earlier, that should not just be this thing you write down somewhere and you leave it. It really should be a specification that is written in a way so you can actually use it to generate stubs that you can use for mocking on the client side automatically. So in that way, you don't have to duplicate that effort. And in the same way, you should use the same specification to validate that the producer implementation actually follows that specification. And that's very important because that means not only do you define a contract in terms of what's supposed to be delivered, but you actually use it to both validate what happens on the server side and on the client side, which means that if the contract is well written, the behavior between them will actually start aligning. And that's really where Spring Cloud Contract comes into play. And it's really a framework for consumers to drive the producer APIs through contracts. What do I mean by that? It means that it's a way to define these contracts in a machine-readable way through DSLs. It's contracts that you store as a part of your source code, manage the same way, and that we can actually use automatically to get some value out of it. That means that we can take these contracts and use them to validate that producer is actually working the way we expect it to. And it means that we can take the very same contracts and use it on the client side to generate stubs. So in that way, if we need to do mocking on that end, we do that based on the very same contract. What's the value of that? It means that we can actually reduce the amount of end-to-end integration testing we need to do, and we still need to do them, of course, but the amount of bugs you're going to find there are then going to be reduced dramatically. Needless to say, Spring Cloud Contract is Java-centric, Spring-centric. You're going to find that if you're using Spring Cloud, we can actually stub out completely frameworks like Eureka, Console, and so forth. And it's got a few different projects involved there, both in terms of helping you use those contracts to validate the service side. On the back end, we also use WireMock to generate more stubs and that kind of things as well. And we also have some neat frameworks into play. So you from a client point of view, can go out there and actually download those contracts on demand and plug them into your project for your testing. So what is a contract? Well, here we got an example of it. And it's essentially a Groovy script. And if you look there, this little example I've got here, it's a login example, calling a login service in the upper half there. You can see that we call this user login service. You provide a username and a password. And then on the bottom here, we were describing, okay, giving that input, this is the kind of output I'm expecting. And I do understand, this is very much a simple example. The real world is a lot more complicated than that. We're dealing with IDs that change all the time, timestamps, and a lot of information like that. And what we do actually let you do when we define these contracts is actually include variable fields like that. So you can say, okay, here I'm expecting a GUID back, that kind of thing. So that we can deal with variable fields, not a problem. So it's actually a fairly flexible framework. So let's do a demo, see how this thing actually works. And I have a fairly not too complicated demo to show you guys. It's based on the same kind of login scenario where I have a login service on the client side that I've implemented, and I provide some credentials there, my username, password. And when I get that, I'm going to forward that to a backend service that says yes or no to those credentials. And the business logic on that is very simple. It's basically that if I get a password in that has mixed casing, then I'm going to say thumbs up, this is a good password. If I get a lowercase password, then it's going to be no. So by all means, this is not a proper login service, but it works great for a demo like this. So let's take a look at this, how this actually works. So first, let's take a look at our contracts here. So where I'm going right now is I'm putting on my hat as a client-side developer. But when it comes to the contracts in terms of how the server-side function works, that is being stored together with the source code of the server-side function. You can actually decouple it completely, so you can have a separate project with just your contracts. It's up to you how you want to manage that. And in this case here, I have two different contracts in here. I have one that describes a user login service with my username, password, and I get an OK result back. And then I have another example here, probably username, bad password, all lowercase. In this case, is not OK. So this is kind of my contract here, defining that I can get positive result back and a negative result back. So what I do then is I can actually plug that into my client code, and I've written some unit tests here that is testing that login function I implement on the client side. So I have the same use cases here, my username, good password, OK, and the same way bad password, not OK. And to wire these all things together, what I've done as well is I have a annotation up here that's telling me that tells Spring Cloud Contract to set up a stub runner. So when I'm running these units tests, whenever I'm calling out to the backend service here, it's actually going to stub out the services that I need in order to make this happen. And the way it actually gets to those stubs is actually through a Maven repository. So really what I'm doing here is I'm referring to This is a package. This is a component where my stubs are stored in a stub section in there. I'm telling it to work offline in this case, which basically means since I'm not on the public internet right now, I don't have a Maven repository on the server somewhere. So in this case, I'm actually leveraging my cached repository on my own laptop for it. So that's what I'm telling it to work offline in this case. And I can run my unit test. We'll now see that, yep, everything runs green, everybody's happy, everything is looking good. Now, after I implemented this and I showed this to the business users, they were like, yeah, this is good, but we've been reading up a little bit on security and stuff, and we feel like just saying that, okay, mixed casing for user and password, that's not good enough. You've got to have mixed casing and some numbers in there in order to make it a valid password. And they're like, okay, we can do that, we'll implement that. So let's change our unit test a little bit. So my password is not good enough anymore. We need my password 123 in order to make that run. And we also want to emphasize that doing bad password with mixed casing is also no longer good enough. So I'll implement those changes for my unit test. And of course, when I do that, these tests are going to run red. They're going to fail because they're not according to the behavior of the service I'm calling in the back end. So what do I need in order to fix that? Well, for me as a client-side developer, there is no way for me to fix that implementation because that's a different team's responsibility to do. But what I can do in this case is at least start the conversation with that server-side team and say, hey, we need to make some changes to the contract we have in place here to accommodate these new requirements that we got. So what you do then is you check out the code from the server-side team, and we're not going to implement the changes for that team. I mean, that's their job to do. I mean, maybe a simple change, maybe a big change. What we can change, on the other hand, is the contract that we have between us and that service. So we're saying then that, okay, it's no longer my password, it's my password 123, then it's going to give me a positive result. And we're going to emphasize, once again, bad password, mixed case, not a good idea. So now I've changed the contract. In order to make those changes available for me when I run my unit tests, I need to do a Maven install, but I'm not going to rerun all the unit tests in there because I really don't care about that. That's not my job. I'm probably breaking something on the server-side implementation, and that's okay. So all I'm doing now is just building that server component with that new contract and putting that in my local Maven repository on my laptop right now. So now I've done that. And I can rerun my unit test, where it's now using a different implementation of those mocked up services. And we can see that, okay, we're good. We've made our unit test run green again. That means, at least from our point of view, in terms of what we're expecting, this is the right behavior. It's what our business users are asking for. So once I've done that, then I can go back to the server team. I can submit a pull request back to that team and say, hey, we made some changes to it. Hopefully we talked a little bit about it in between there so that it doesn't come as a big surprise to them. But we made those changes to the contract, and it's up to them to pick up on those changes whenever they actually have time to do it. So once they're ready for it, and I kind of changed hats here from being a client-side developer to a server-side developer, I could take a look at these changes, and I can say, well, yeah, that looks okay. I mean, if that's what they want, we'll fix that. And the first thing I can do then is actually run some unit tests to see if my current implementation aligns with that new contract. And the way you can do that is we have a plugin as a part of Spring Cloud Contract where we actually on the fly generate unit tests based on those contracts. So I can do a Maven test of my server code. And we're going to see here, build failure, something went wrong. We run some unit tests, one error here. And if we look a little more in the stack trace, what happened, we're saying that somewhere here, we got an OK when we really expected a not OK result. So here I can see suddenly that my implementation of my server code does not fulfill the contract that I have with my client. Lucky for me, I know exactly what the problem is, and fixing the bug is not too complicated. So let's just fix it. Down here has got some code. This is my authentication method. When getting the password, and up to this point, I've been making sure the password in there somewhere has a lowercase, at least one lowercase letter, and at least one uppercase letter. And the only thing I need to do is add another check to see that we have at least one number in here between 0 and 9. So I implement that change, rerun my unit test. And we're good to go. Build success. Everybody's happy. We're all good. So in that way, we've taken that change in the contract. We've fixed our code. We can check it in. Everybody's happy. And the only thing that needs to be done after that is to communicate back to the clients and developers that, hey, we picked up that change you made to the contract. This is looking good. We've implemented. We checked it in. So in that way, the only change that the client-side developers can do then at some point is to update their test. I'm saying up here, work offline, change it from true to false, which basically means that when you run the unit test, we're going to download this component here, and we're going to take it from our own hosted Maven repository instead of trying to rebuild that component ourselves. All right, so let's get back to our presentation. So really, what have we achieved by doing all these things? Well, two things. First of all, we improved communication. We've taken the type of information that ends up often in a Word document that becomes immediately stale after it's been written, and we turn it into an artifact that we can actually put to good use. So that means we're actually taking that information, that contract we defined, not only can we use it, but it also means that we'll actually keep on updating it afterwards, because there's an actual incentive for us to keep on updating that documentation. It also means that we're reducing the risk of failed integration tests. They can still go wrong, but if you look at the kind of integration test failures you'll have, chances are a lot of them you can actually write back to, okay, if we had a better defined contract between our teams, we can have avoided those failures in the first place. That also means we get a better API in terms of that is something that also aligns better to what the consumer needs. And it means that that API, that contract you use, is managed as source code. You can use it for verifying the actual implementation, the server implementation, make sure that one is good. It also means that you can use the very same contract, the very same specification to mock up your own implementations as well that you can use on the client side. So thank you. That's all I had for today. Any questions? Yes?
So it seems a lot like you guys did your DSL for the specification. Is there any way to use something like Swagger Stack or something like that instead of so that if we're already focused on documenting that way, we don't have to document it two different ways?
So the question is, do we have to use this DSL language? The answer is no. There are ways to use other types of specifications as well. I'm not sure if we have support for exactly the notation you guys are using there, but at the end of the day, we're open source, we're friendly, so we'd be happy to work with you if that's something you're looking for. Another question? I'm sorry, I can't hear you. Yeah. Just saying that there are ways to do it. So if you gentlemen want to talk together afterwards, that's up to you guys. Any other questions? All right. Well, thank you so much, everybody. Sorry for running a little bit over, and I do appreciate hardly anybody fell asleep. So that's fantastic. Thank you very much.